Okay, so this probably won't take 30 minutes. And we talked about a lot of this yesterday at the Ask Me Anything, so I can probably speed things up a little bit without affecting any the understanding. So the firmware for Access's devices is built using OpenEmbedded or Yocto. Yocto isn't the same thing as OpenEmbedded, but the distinction is often not very important. Because although our products, of course, contains a lot of Access proprietary source code, mostly it's based on open source code. The Linux kernel and all the user space things and various libraries for many things. So I think something like 80% is open source. And we use them. We won't want to be able to use the upstream source code without any particular import process and so on. So OpenEmbedded uses a sort of big build tool called Bäck, which it builds software, but not in the same way as Make, Meson, Ninja, CMake, or whatever you might use. It's more of a sort of higher level build system that invokes other build systems and eventually produces either it could be a file system tarball. In our case, it's an image we can download into our devices. So it does this by having a collection of so-called recipes, where you would reference the source code and at what revision it is, and you would somehow indicate what should be done with the source code. So in this particular case, you would inherit the AutoTools class, as it's called, which basically tells Bäck that you download the source code and then you run the configure, make, install, the standard stuff for a lot of software. You could also set additional variables. You could have variable references inside these strings. You can even have arbitrary Python code in these recipes, which makes it pretty painful to parse. So it's not just simple configuration files. It's a lot more complicated than that, which is one of the challenges. So our source code contains not actual source code directly, but about 2,000 of these recipe files. That's sort of our platform from which we build the source code. And this poses a bit of a traceability challenge. So if these are the repositories of actual source code that people make changes to, they are down here. They are referenced in these recipe files that reside in other source code repositories called layers. So in here, you would have recipe files saying that of apps foo, we should have the tag r1.9.0, for example. And again, you would have about 2,000 of these. Recipes could produce binaries. They could also just install configuration files or data files. That's whatever you need in your file system, you could have. And then you have multiple layers. So we would bring in some layers from upstream that contains basic components of the system. On top of that, we layer our own additions, or they could possibly replace or sort of shadow recipes that are in the lower layers. So when evaluating the whole system, you need to take that into account as well. And somehow we need to connect all the layers as well. So we do have a single source repository that we can tag that selects the whole source code, but it does so in multiple layers. So to be able to figure out at what tag of this repository here did we get 1.9.0 of apps foo is suddenly not entirely trivial. I'm sure a lot of our developers have written scripts for doing this, or they would read the change logs for the layers, where we have pretty strict rules on how they should be formatted, the commit messages. And one of the reasons for doing that is to make it easy to see when changes are actually introduced down here. But that's sort of a workaround for the fundamental problem of this multi-layer structure. Right. So yeah, we talked about the first bullet, namely that source code references are layered or nested in a way that makes it pretty hard to get traceability of, Eiffel or no Eiffel. Recipes, as I mentioned, can reference variables, not only from the same layer, but also from other layers. So you can't parse the recipes in a layer separately from anything else. You need to parse the whole platform, the whole state of the source code. And as I mentioned, recipes can shadow recipes from layers further down in the stack. So you need to understand how this works. I think we avoid doing that for the most part. Oh, and not only shadow, you can actually sort of patch recipes in a lower label using files with a different file extension. So you don't have to replace the whole recipe, you only patch in certain variables. And I think there are like 8 or 10 or 12 different ways of assigning variable values. So you have the prepend and append, and you have different notations for that. So it's like a language that has evolved over time. And originally they probably just had simple assignments, and then they realized, oh, we probably need prepend and append assignments, and then yeah. So it's not that fun to parse. And again, you can have arbitrary Python code sprinkled in as well. But this is surprisingly somewhat, it's actually widely used in several places. So of course, why not use Bäck then to just resolve all of this? That would be the easy thing, and it would do all the parsing for us. Well, there are 2 problems with this. First of all, it always evaluates these recipes for a particular configuration. In other words, for a particular product. And we have about 100 products. So we would want to have the union of everything if we want to track what source code goes into a particular build. And secondly, it's slow. It takes 2 or 3 minutes to resolve everything. And if we could do that just once, that would perhaps be acceptable. But if we have to do 100 times, we can't do that. To solve the traceability, we have started to produce Eiffel compositions for this. And this is really exactly what we talked about yesterday and with Azim's question. And we produce 2 kinds of recipes. First of all, we produce compositions that detail what is in a layer. Again, we have a couple of layers, 2 or 3 that are actually relevant. So the composition itself has a name and a version that describes what is it we are describing, what state of the layer are we describing. But we also have a cause link to the source change event that exactly describes what it is we are describing here. And then we have element links to all the tags that are referenced in the layer. Now, as I said, layers are not independent. So I'm not super fond of producing this composition because I don't think it's that useful, because it is not complete and it could be incorrect in some cases. But other people wanted it, so we created it anyway. The more useful composition is similar, but it looks at the whole platform. So again, we are triggered by a source change event of the whole system. And we then produce a composition that links to all the repositories and the tags that are included in the platform. And this includes, again, all the repositories, regardless of whatever product they might end up in. There are probably repositories that don't actually produce any files that end up on any product. That's quite possible. So we had this in production since the spring, I think. And I'm not sure if it's used in the visualization program that I showed yesterday, but it certainly could be. So with this, it would be possible to compare two releases and see what exactly are the differences, both in terms of the tags themselves, but of course this artifact links back to the actual source changes as well. So you could use it to inspect and get the full diff. And you could also use it, since we are triggering it based on source change created events for the whole, submitted events rather, of the whole system, we can use it to see whether a particular tag has been integrated at all. Because originally we have this tag, but when we get this composition, we know that it's actually part of the whole platform. Because that fixes a problem of knowing when has your change actually been integrated. Submitting a change and tagging it in a sort of code repository, that doesn't mean anything. Since it's the update of the layer that references the source code repositories that actually includes it anywhere. That's what matters in many contexts. That's the last slide. Any questions or comments?
So we had this discussion about source code events, and you had a proposal of introducing new ones. Would there be any changes or simplifications on the picture here?
Unfortunately not. It would make other things better, but it wouldn't really change this right here. What we could, that's probably out of the scope for that discussion, but there's a related problem of how to deal that I filed an issue for, how to deal with other kinds of hierarchical source code hierarchies. You know what I mean? Like if you use submodules, for example, ideally you would want the source change event of the supermodule to somehow link to the other submodules, but that's not possible today. So the only way of dealing with, if you want to express a submodule structure, you would have to do something similar. And so that's probably, you could have actually generic open source component doing that. But again, it would work in the same way. It would have to trigger on source change creations or submissions, analyze the reference submodules, and then emit a composition similar to that. I don't know if that's the best way of doing it, but it's currently the only thing we can do. And that wouldn't be helped by the new source code events that we've discussed earlier. And I don't know the problem. The problem is it's figuring out what some modules are referenced it's not difficult, but it certainly increases the complexity in whoever emits the source code events. And it might be wiser to have it outside of that event producer.
So when it comes to these tags you're talking about, you're using the created event to identify a tag. Are you happy with that, or is it something you're missing there?
No, we're not very happy with that. We're doing what you guys are doing because there is no really good way of doing it. But I mean, there is also an open issue about creating possibly a new event type for describing tags or other forms of immutable source code aliases or whatever terminology you want to use. But that's covered by the source code events that we have suggested, I believe. But yes, we were following where we're doing what we think you guys are doing with an artifact which I've abbreviated here, but it should, apart from including some representation of the repository name and the tag, it also has a VCS URI qualifier in the artifact ID, And this event links back to a composition that also describes this. And that composition in turn points to the actual code commit. But it's a fairly awful workaround for a lack in the protocol, I think. But it's what we have right now. And it's also it's not trivial to search for. If you have a repository name and a tag, finding this event isn't super convenient. You probably need to have to search for the composition. If you know what the composition is named, and that's probably something local to your company, and then you would have to do a search forward in time to find the artifact creation. Or you would have to construct the whole artifact, or the artifact identity, and then you need to know exactly what it looks like. And you don't want to do wildcard searches of the data.identity member, because that's going to take a long time in your event repository query. Okay, any other comments, questions?
One more.
Yeah, go for it.
Usually today there's talk about bill of materials. So for example, if you get a lot of components in, you want to know, okay, what they are. Maybe bill of materials is something that is difficult to describe as you're doing source code integrations. But do you have any like requirements there to track down, okay, what's at each build of a system that you have the requirements to trace at that point, whatever what got in?
Well, eventually, if we want to sell devices to the US market, we're going to have to produce a bill of materials, yes. So that requirement hasn't turned concrete quite yet, but yes, we will start producing software bill of materials. However, not using this, but OpenEmbedded has its own system for producing bills of materials in some kind of SPDX format, I think. Okay. So that's what we're going to use.
But that won't help you with this problem.
I don't know yet. We have barely started using that, but it is possible that we could maybe use those. Well, the problem with that is it will be produced during the build, and it will probably be product specific. Yes. So yes, if we would be happy with getting these compositions over here after we've built all of the products, which currently takes place once every day, every weekday. If that would be good enough, then yes, we could probably transform that into Eiffel. But I'm not sure that would be that much easier. I haven't looked at the exact file format, and it would be delayed by the build.
Okay, and the bill of material doesn't, maybe I'm not thinking clearly, but the bill of materials wouldn't solve the problems that they need Eiffel was today.
Maybe, but you would probably want to get it into another representation anyway.
Okay.
Since you would have some kind of data file for 100 different products, and that's not in a searchable format. So even if you don't transform it to Eiffel, yeah, but you would probably have to transform it into some kind of more convenient representation either way.
Oh, okay.
So Eiffel or no Eiffel, yes, but work required. But again, I'm not too involved in the software bill of materials discussion, but it's things are moving in that space. Okay, thank you.